Okay, hello. We're going to take a look at what we did today. So we did 2.2, the last part. So we warmed up with this question, what percent of the data for this scenario fall between 61 and 89? So if we look at, I marked out standard deviations and means already on the picture on the number line. So keeping in mind for normal distribution, the mean always goes in the middle and we go up 3 standard deviations and then down 3 standard deviations. So we want to see what percent of the data fall between 61 and 89. So for our question, we want to examine, are we at some special points? So we decided we were at 2 standard deviations each way. So the pattern that we get is 95% of the data is between those 2 standard deviations. And so, or is within 2 standard deviations. So the percent of freshmen at EK that took this algebra test and scored between 61 and 89 is 95%. So that's how we would find that. Those are using what we did yesterday. Then we went on to this question. So this is where we're getting into things. So we've got our situation from yesterday. So we have the same curve. Ooh, that's not very symmetric, but making it work. Okay, so we're going to label our curve. Whoa, 5s where they don't belong. And then we're going to mark out our standard deviations from yesterday. So 87.7, 95.4, 103.1. If I go backwards, totally cheating a little here. Make sure I do the right math. 72.3, 64.6, 56.9. Okay, so now what I want to look at for is the question. It says less than 68.45. So let's mark out where that would be. 68.45 is going to be here. And it said less than, so I'm trying to find this area. Now, what we discussed is that this is a problem because it's not on a special spot. So if it's on a special spot, I can use my percentages to figure out what's going on, but I am not at exactly 1 standard deviation or 2 or whatever. I'm not at any of these special locations, these nice numbers. I'm in between them. So we kind of talked around a little bit like, well, how would we find this? I could estimate, we could eyeball it, we could cut, this section here in half and take that percent and kind of add them all together. But the point is we don't have an accurate way to find it if we just eyeball it. And real life tells us that we have data that's not going to always fit exactly on 1, 2, or 3 standard deviations above or below the mean. It's just not going to happen. Let's take a look then at what we would do. So in your notes, there's a reference table. You're going to want that. So for the first question here, it says what percent of the runs will be greater than 85. So I'm going to mark that out. That's the first thing we want to do is show where we're at. So 85, I don't know, look about here. And it said greater than, so I'm going to shade above that. So 85. And then we need to figure out where we're located. Ooh, switch the slide might help. We want to figure out where we're located. So what we're going to use is our table. This table has all of the different possible areas for different locations on my curve. Now, real life data is not the same like every time. Like I'm not always going to have these numbers, right? I mean, this is just specific to this situation, hence why I've labeled it. So what we need to do is standardize our values so we can look them up on the chart. So this is a standard normal chart. So we have to take our values in context and convert them so we can look them up on this chart. What we're going to convert them to is just a z-score. We're going to figure out where we're located in terms of a z-score. So if I do that, I'm going to have 85 minus 80 divided by 7.7. which is going to give me a z-score of 0.65 if I math that out on a calculator. I go up to my table and I use this first column to find 0.6. So the first part of my number, and then the hundredths place is whatever column I'm in. So that would be 0.05 or a 5. And now I just want to go over and down and find my little percentage, which is right there. So I want to kind of label what I've done in terms of my z-scores. So just to kind of show like, okay, we have our context here, but then also I know I need to find a z-score for it to put it on this like standard distribution. So the standard distribution is always 0 and 1. It's going to center at 0, and you're 1, 2, or 3 standard deviations up and 1, 2, or 3 back. So for ours, 0.06 is going to be about here and on up. So we want to mark that out. So it's showing that we're basically linking the two ideas. I can take my context, but I can convert it. I can standardize it to fit this table essentially. So when I go to the table, the only thing about the table is they got to keep it consistent. So it's not like 20 pages long. The table is marking things always to the left of your z-score. So it's giving you percentages that are less than what you want. So in this case, the 0.7422 is less than my mark. So it's lower than where I want. I just want the other side. So I want the greater than side. Remember, this all adds to 100% or to 1. So I take 1 minus the part I don't want. I'm going to get the part I do want. So if I math that, I already have my key here, speed it up, but 0.2478. So that would tell me in percentages. Some people like to think of this in percentages. I'm 24.78% of the runs, or of the speeds of this car are greater than 85 miles per hour. So in this distribution, since it's normal and where I'm located, that means I'd have about 25% almost of my data at 85 or more. So the next thing we want to look at is another situation with this is between. So how would I look at a between situation? So in this case, they want to know what's between 70 and 95. So I'm going to mark it out. So 70 and 95 is almost at 2 standard deviations, but no dice. Not quite. Shade this part that I want. And now I have 2 locations. So I'm going to have to get z-scores for both of those to standardize it and figure out where the heck I'm at. So z-score for the 70 will go 70 minus 80 divided by 7.7. Is going to give me a z-score of negative 1.30. And then the next one, just realized I could take this off. The next one, we've got 95 minus 80 divided by 7.7. So I got a z-score of 1.95. So let's label that on our standard normal distribution. So I've got, and this just make it kind of look accurate. Just remember zeros in the middle. So negative 1.3 and 1.95. I'm shading the same thing. These obviously kind of look the same. It is the same space. Just one's on the off the table. So okay, let's take a look. I'm going to switch colors. We're going to find our z-scores. Or our areas for each of these z-scores. So for this one, 1.95, I already have that one circles. I have 0.9744. And then for this one, I don't have the screenshot, but there are 2 sides to your thing. So if you're not seeing negative numbers, flip over your paper. And we're basically at the negative 1.3 row, and then the first column, which is the 0 column. So if I do that, I'm going to get 0.0968 for my area. So I have 2 different areas. Here's how we can look at it. The z-score chart, remember, gives us everything to the left of our location. So for this first one, that's from 1.95 all the way down, has an area of 0.9744. And then the other area is from there on down. Notice this area I do not have shaded, so I don't want that. So I have the whole piece and then a piece within that I don't want. So I'm just going to subtract to get what is in between. So in this case, if I math it, punch it on the calculator, I'm going to get 0.8776, or 87.76% of my runs are between 70 and 95 miles per hour. So that's a between situation. So let's look at one more. This is working backwards. So the last question is asking you for the top 15%. So let's mark it out. We're going to kind of estimate. So like 15%, I don't know, about right there. So I know this area is 0.15, but I don't know where I'm located. I mean, I could estimate, right? I mean, I know I'm between like 87.7 and 95.4, but I want to be accurate. So in this case, we're going to work backwards. So we're going to use the Z-score chart and work, or the standard normal chart and work backwards. So just remember, the standard normal chart always gives us the area to the left. So if we want to be in the top 15%, that means 85% of people are below us. We're doing better than 85% of people, and then there's 15% of people doing better than us. So let's take a look at how we'd find it. It's a little tedious. So I'm right here, and I know this is 85. So on my Z-score chart, I'm looking for 0.85 is what I'm looking for in the body of my table, because these are all the areas. So I'm working backwards. I've got the area, but I got to find the location for that area. So I can see right there is about as close as I'm going to get to 85%. So that has a Z-score, if I backtrack here, of 1.04. So I'm going to work backwards in my formula to get what location I would need to be at, like what's the digit like that I would have to plug in to get a Z-score of 1.04. So we're going to do algebra. So I'm going to multiply by 7.7. So get rid of that. So that's going to be 8.008 equals question mark minus 80. And if I add 80 to both sides, doing a little algebra, my question mark is going to be 88.008. So this is not a percentage now. This is the miles per hour that I would have to drive in order to be located here and be in the top 15%. So those are the three question types. Basically taking a location, figuring out where you're at and what percent would go with it, or what location you need to be at to be within a certain percentage. So these are our important ideas. Basically, we just follow this process. This is what we just did. So you're going to draw and label your curve, two of them. So context, and then where your Z-score would be. So showing both locations, linking that idea. And then you're going to shade, marking out, doing all your shading stuff. Do your calculating. So show your numbers plugged into the Z-score formula. Use the table. And then conclude, basically coming up with your number. And Monday we'll practice doing some sentence writing. So Monday, we'll be looking at the review questions in the packet to practice this stuff. So because this takes a little bit of practice to get it all in your head of what you're doing. So that's it for today.